All right, today we're jumping into a really cool AI system from Krzysztof Gwóźdź. And this isn't just another small improvement, it completely rethinks how AI should learn and react. It's a story all about speed, about reflexes, and believe it or not, a mysterious bug that almost brought the whole thing crashing down. So yeah, let's get into it.
You know, we're surrounded by these incredible AI giants like ChatGPT and Gemini. I mean, they've practically read the entire internet. They're super creative, they're powerful, but they've got this embarrassing little secret. They can be painfully slow to learn new things. And what's worse, they can totally flub simple math problems. Now, this isn't just some funny quirk. It actually points to a really big limitation in how they're designed.
So here's the core issue. Most of the AI we use today is like a giant static library. It takes months and months to build, and once it's done, its knowledge is pretty much frozen in time. But the real world, it's not static at all, right? It demands a fast reflex, the power to adapt in milliseconds. And that is exactly what this CUDA Phase Reservoir system is built for. It's not meant to be a bigger library, it's meant to be a faster reflex. Okay, so first, let's really dig into that hidden flaw. I mean, why are these massive AI brains with literally billions of parameters so weirdly fragile when you ask them to do specific logical tasks? Because if you understand this problem, you'll really appreciate why this new solution is such a game changer.
Let's just break it down. First off, these models are trained for months on data that's already out of date by the time they launch. So they're not built to learn on the fly. This is what leads to them hallucinating. That's when they essentially just guess, especially when they're faced with precise logic or math. You know, for the quick rapid-fire calculations you need in robotics or real-time data analysis, they are just not the right tool for the job. And that brings us to the hero of our story, a completely different way of thinking about AI. Instead of just going for sheer size and cramming in more knowledge, this system is all about speed, efficiency, and, this is the key part, the ability to learn as it goes. The technology is called reservoir computing, and a great way to think of it is as a lightweight brain. So instead of training this massive, complex network from the ground up, it uses a fixed dynamic reservoir of nodes. Imagine you drop a pebble into a pool of water. It creates this complex ripple pattern, right? Well, the system only has to learn how to read those ripples, which is incredibly fast. It doesn't have to rebuild the whole pool every single time. So how in the world does it learn so fast? Okay, an input signal, let's say a math problem, gets sent into the reservoir. The reservoir then acts kind of like a prism, turning that simple signal into a really rich, complex pattern. Then a super efficient algorithm just has to learn how to read that specific pattern and connect it to the right answer. And because it's only learning to read patterns, not change the entire system, it can adapt in just milliseconds. It's literally learning in real time. But you know, the road to get here wasn't exactly smooth. In the early days, the whole project was hit by this bizarre and really critical failure, a strange bug the creator called the twin collision incident. And honestly, it threatened to sink the entire concept. So the central mystery was this. The system was built for precision, but it seemed to be completely blind to tiny, subtle differences in the data. How could a system that was designed for logic fail at something so basic? Okay, so here was the exact problem. The system was given two totally different math problems, 37 minus 66 and 36 minus 76. To you and me, they're obviously different, but to the AI, it saw them as exactly the same thing. It was creating the same internal ripple pattern for both, which made it impossible to learn that they had different answers. So after weeks of digging into this, the conclusion was actually pretty startling. The problem wasn't some deep flaw in the reservoir brain or the learning algorithm. Nope, the brain was working just fine. The problem was with its eyes, the way it was seeing the input data in the first place. A classic case of garbage in, garbage out. So the next question is, how do you fix a system's eyes? Well, the solution, as it turns out, was surprisingly simple. And fixing this one bug didn't just solve the problem, it completely unlocked the system's true potential. So here was the culprit. The original faulty input method was treating the math problems like a bag of characters. Think about it. 37 minus 66 and 36 minus 76 had the exact same set of characters, a 3, a 7, a 6, and another 6. So of course it saw them as identical. The fix was to build a new parser that understood the structure and the position of the numbers, not just what characters were in the bag. And the result? It was immediate and it was dramatic. This one number tells the entire story. The separation distance, which is just a fancy way of saying how different the two math problems looked to the AI, jumped from basically 0 all the way to 87.8. Just like that, the system wasn't blind anymore. It could finally see. The twin collision was solved. Okay, so the system is fixed, it's working perfectly. What does this actually mean for the future of AI? Well, the goal here isn't to replace the giants. The goal is to become their essential partner, a kind of specialized co-processor that can handle all the stuff they're bad at. And there's actually a name for this idea. It's called a complementary learning system. It's an architecture that's basically inspired by our own brains. You've got your cortex, which is like a huge knowledge base that learns slowly. And then you pair it with something like your hippocampus, which is a fast, adaptive system that learns new things super quickly. A perfect analogy for this is a freight train versus a Formula One car. An AI giant like AlphaFold is the freight train. It's carrying a massive amount of knowledge, but man, is it slow to change course. This reservoir system, on the other hand, is the Formula One car. Sure, it has less total capacity, but it has unbelievable speed and agility, and it can adapt to a changing racetrack in an instant. So what does this look like in the real world? Well, in practice, it means this system can act as a specialized partner. For something like ChatGPT, it could be a neural calculator that gets rid of those math hallucinations. For a game-playing AI like AlphaZero, it could provide fast intuition, letting it run millions of quick simulations. And for robotics, it could offer dynamic understanding, letting a robot adapt to physical wear and tear on its own parts in real time. Ultimately, what this whole project proves is a really profound point. For so long, we've been focused on building AI with more and more knowledge. But maybe we've been missing half of the equation. Because true intelligence, it isn't just about what you know. It's about how quickly you can adapt to a world that's always changing. And that leaves us with a really fascinating question to think about. As we keep building this future, what's going to be more important for creating truly intelligent systems? Just making bigger and bigger brains, or engineering much, much faster reflexes?